Hi everybody, this is a video about solving rational equations. In order to solve rational equations, you must find a common denominator first. So let's fill that in. And that's what the adding and subtracting rational expressions video talks about, how to find a common denominator. And the reason that we're going to do that here is to pretty much ignore the denominators. So if we can make all of the denominators match, really the equations are only going to focus on the numerators. So let's do this. Let's make our common denominator. So we're looking at a 2, an x, and a 2x. Our common denominator would be 2x. So I'm going to multiply this first fraction, top and bottom, by x, and the second fraction, the top and bottom, by 2. And then I wouldn't need to multiply the third fraction by anything. So this is now 5x over 2x plus 6 over 2x. And that equals 16 over 2x. So now that all the fractions have a common denominator, we are really just going to focus on the top. So really 5x plus 6 needs to add up to 16. So let's solve that equation. We'll subtract 6 on both sides. And that becomes 5x equals 10. Solve for x by dividing by 5. And we get x equals 2. Now, the one thing that we do need to check for would be extraneous solutions. So does 2 make the denominator 0 in any place here? No, that's not the case. So we get 2 as the solution. Let's try another problem. All right. So we have a denominator of x minus 1, x plus 1, and another one of x squared minus 1. So let's start this one off by factoring the x squared minus 1 into x minus 1 times x plus 1. And now every one of these fractions, we want to make sure that it has the same factors. So our common denominator is going to be an x minus 1 and an x plus 1. So very similar to the one we just did. So this fraction in front here, that's missing an x plus 1. So we'll multiply the top and bottom by that. The second fraction is missing the x minus 1. We'll multiply top and bottom by x minus 1. And then the third fraction doesn't need anything. So this, we're really just going to focus on the numerators here, is really a 3 times x plus 1 plus 5 times x minus 1 equals 14. And now let's distribute this 3. So we get 3x plus 3, and distribute the 5 plus 5x minus 5. That equals 14. And then we'll add the like terms. We get 8x minus 2 equals 14. And then we'll solve for x by adding 2 to both sides, and then dividing by 8 on both sides. And before we circle, we just consider if 2 could be an extraneous solution. Does 2 make any of the denominators 0? Nope. So 2 is a good answer. Let's try another problem. All right, so it looks like we have x squared, and x cubed as the denominators. I'm going to say that the common denominator should be x cubed. All right, so we would need to multiply this x by x and x in order to get x cubed. The second fraction we need to multiply by x on the top and bottom to get the x cubed, and then the other fraction is fine. So this becomes x squared plus 5x equals -6 if we ignore those denominators. That's a quadratic equation. So to solve this, we need to set it equal to 0. So I'm going to add 6 to both sides to get that equal to 0. And then from here, I think we can factor this one. Let's do that. X plus 3 and x plus 2. So we get x equals -3, x equals -2. And neither of those things make the denominator 0, so they are both good solutions. All right, it is time for you to practice some of these on your own. Good luck.